Hello guys, welcome back to Mason African Motives, still on mathematics for grade 10. We are going to focus on revisions using the question paper, which I took from the Eastern Cape Province. That is a national certificate, as you can see, guys, November 2020 paper. So we are going to quickly rush through the questions so that we can see actually what we had. Taking note, the paper is supposed to be actually 2 hours and it's 100 marks. All right, so let's see what we had. The instructions, make sure you read your instructions carefully. And the most important part is the degree of accuracy. If necessary, round off two decimal places unless stated otherwise. Yeah, that's the most important part. And the rest, you have to read as much as you can. All right, so we are given on question number 1, to factorize the following expressions fully. So take note, this is fully factorized. All right, so let's see 1.11 where we are given 4y squared minus 16. So the first thing to cross-check is that we have any common term there between 4 and 16. Yeah, 4 is the highest common factor. So that means we can factor out 4. If we factor out 4, we divide 4y squared divided by 4, that is y squared, minus 16 divided by 4, that is 4. If we are to cross-check, what we are remaining with is a difference of 2 squares, which can be written as y squared minus 4 is same as 2 squared. So that means we're going to have 2 brackets that we are going to add and subtract the 2 terms, that is y and 2, which is the square root of y squared, which is y, the square root of 4, which is 2. So one is going to add and another one is going to subtract. So it's now in its simplest form. There's nothing that we can do on this one. All right, x cubed minus 1. Remember, this one is actually an identity. You are supposed to know the identity that if you factorize x cubed minus 1, it gives you x minus 1. All right, so that's the identity there that we have. So it's x minus 1 into x squared plus x plus 1. All right, everything over. Already we are given x squared plus x plus 1. So this can cancel out together. So which means you are going to remain with x minus 1. All right, since this is canceled each other. All right, on 1.13, we have got x minus 1 plus y minus xy. All right, so we've got 4 terms. So by grouping, we can group this into 2. For the first 2 terms, since here y is common, so we can just leave the first term terms as they are, that is x minus 1 as it is. You can factor out 1, then it remains as x minus 1. Here we've got y minus x. So we are supposed to factor out the highest common factor that is going to enable the same brackets to be there. So our x is positive, but you can see here our x is carrying a negative on that side. So definitely for it to be a positive, you're supposed to factor out a negative. So you're going to factor out negative y. Y is common, but we'll factor out with a negative such that positive y divided by negative y, that's negative 1. Negative xy divided by negative xy. Negative and negative will cancel to give us a positive. Y and y cancels, you remain with x. So these 2 brackets are the same, x minus 1 or minus 1 plus x. As you can see, 1 is still having a negative, is having a negative here. X is a positive, x is a positive there. So that means we are going to have the common bracket of x minus 1. And we are going to remain with 1. If we factor out x minus 1, here we remain with 1. Here we remain with 1 minus y. So this is going to be 1 minus y. So that was the factorization part, guys. As you can see, 1, 2, 2. That's 5 marks of factorization. All right, let's see the other part of the question. I'm just going to remove this part so that we can utilize the page again. On 1.2, we're given to simplify the following expressions fully. So it's just simplification. So what are we required to do on 1.21? So we've got part of factorization there. So here we can factor out the 3. It's common here. So let's factor out the 3 and see what you're going to have. Plus 3 divided by 3, which is 1 minus x. All right, over here I've got x squared minus 3x plus y plus 2, which is a quadratic expression. So the coefficient of x squared is 1. We can take that as an advantage that you're going to just have 2 brackets affected by x squared. I have two factors here, x and x. Then we focus with the constant term, which is positive 2. What are the factors of 2 that when you add, they will give you the middle term, which is negative 3. So factors of 2, we've got negative 2 and negative 1. If we multiply, we get negative 2. If we add, we get negative 3. So that's negative 2 and negative 1. So this is negative 2, negative 1. But we can see that here, these two brackets are similar to each other, only that the x here is a negative, 1 is a positive. Here, x is a positive, 1 is a negative. So what are you going to do? You're simply going to factor out a negative from this bracket so that they will be the same. So if we factor out a negative, it is going to be negative 3. Then 1 is going to be written as negative 1. X is going to be written as positive x. That's if we factor out a negative from that bracket. So we've got x minus 2 and x minus 1. So these two brackets are the same. You can even write in this way, minus 3, x minus 1, so that you can clearly see that these two brackets are the same. So you can cancel out the x minus 1 and the x minus 1. They are the same. So which means we are going to remain with negative 3 over x minus 2. Is there anything that we can do from this stage? There's nothing. So you just have to leave your answer like that. All right, let's see the 1.22, what we had. So let's just remove this part so that we can work this question aside. If we are to check our question, we are given consideration where we're dealing with exponents. We've got 16 to the exponent of negative x by 12 to the exponent of x plus 1. I always say that try by all means to write these numbers in simplest form. The simplest numbers that we have in this case is 3 and 4. Yes, you can write 4 in terms of 2, but 16 we can obtain 4. From 12 we can obtain 4. So that means we can leave it like that. So knowing that 16 in base of 2 is this, in base of 4 is same as 4 to the exponent of 2, which is going to be multiplied to minus x. So it's 2 times negative x, which is negative 2x. Multiplied by, we can check here, we've got 12. So let's write 12 in terms of 3 and 4. That's 3 times 4. All right. So writing 12 to the exponent of x plus 1 is same as 3 times 4 to the exponent of x plus 1, knowing that each and every number is supposed to be affected by the exponent of x plus 1. So it is going to be 3 to the exponent of x plus 1. We also affect 4. So it's going to be 4 to the exponent of x plus 1. Everything over 3 to the exponent of x and 4 to the exponent of minus x. So these are in simplest form since we have got 4 on top, we've got 3 on top. So now we are going to apply the laws of exponents, where we know that if we are multiplying the bases which are the same, we add the exponents. So it's x by x to the exponent of b gives us x to the exponent of a plus b. If we are dividing, then we subtract. So here we are multiplying 4 to the exponent of negative 2x and 4 to the exponent of x plus 1. So you're supposed to add the exponents, which is negative 2x plus the exponent of x plus 1. All right, we still have another 4 here in the denominator, which is dividing. And if you are dividing, you're going to subtract. So this is going to be minus the exponent, or the power that we have on x is already having a negative. So it's going to be minus x, which is going to give us a plus. All right, we are done with 4. We move on to 3. It's multiplying here. So it's going to be 3 to the exponent of x plus 1 that we already have, then divided to 3 to the exponent of x. So we are going to subtract the exponent since we are dividing the bases which are the same. So we can simplify as much as we can on top here. This is 1x, negative and negative becomes a positive x. So it's like positive 1x actually. So it's negative 2 plus 1 plus 1, which is a 0. It's negative 2 plus 2, which is a 0. So x is going to cancel out. We are left with 1. So this is going to be 4 to the exponent of 1 by 3 to the exponent of, we've got 1x minus 1x, which is a 0. So you're going to remain with a 1. So this is going to be 3 to the exponent of 1. 4 to the exponent of 1 is same as 4 times 3 to the exponent of 1, which is same as 3. So 4 times 3, that is 12. So that's what you're going to have from that one. So as you can see, guys, some of these questions, they'll be clearly be given. All you need is to make sure that you simplify properly. remembering the laws of exponents whenever you're dealing with exponents. All right, on 1.3, we are given a certain statement that given that, all right, let's just remove this part so that you can see our question properly. We are given that m is equal to x into x minus y squared. Determine the value of m if xy squared is 4, x cubed minus 2x squared y is equal to 3. All right, well, how do you answer this type of equation? Simply expand, okay, so that you can obtain these given values. So let's expand. M is equal to x into x minus y squared. So if we expand the identity here of x minus y squared, it's going to give us x squared minus 2xy plus y squared. Remember your identities, guys. If you've forgotten this, then get back to the normal expansion where you're supposed to expand 2 brackets x minus y into x minus y. So that's x and x, which is x squared, x times minus y, which is minus xy, minus y times x, which is minus xy, minus y and minus y, that's positive y squared. So you can collect like terms. That's -1, which is negative 2xy plus y squared. So you can expand using the longer way of expanding the other bracket to the other one. All right. So at this part, we can expand by x, that is x times x squared, which is x to the exponent of 3. Then we have got x and minus 2xy. So the x here is going to affect this x here. So it's going to be minus 2x squared y. Okay, then x and y squared, which is going to be xy squared. All right. After you have expanded, then you are supposed to get back to the information that you're given here. Xy squared is equal to 4. We have xy squared here. So this value is equal to 4. Wherever we see x cubed minus 2x squared y, we are going to substitute with a 3. And we have that here, x cubed minus 2xy here. So that means we are going to substitute now with the numerical values that we are given. So this part is represented by 3. So it's 3 plus, there is a plus here, so you're going to add 2xy squared, and xy squared is equal to 4. So it's 3 plus 4, so m is equal to 7. So these are the typical questions, guys. That's how they actually ask these questions. So be careful, work with much question papers so that you'll be able to understand how do they ask these questions. All right, so that was actually a total of 14 marks. Question number 2, we are given to solve for x without the use of a calculator. These are equations, so no calculators. Okay, so 2.11, we are given a cubic equation, which is of x cubed is equal to 9x. So what can we do? We can just transpose x to 9x to the other side of the equation. So it's going to be a negative. So this will be x cubed minus 9x is equal to 0. X is common between the two, so you can factor out x here. X cubed divided by x, that's x squared, minus 9x divided by x, that is negative 9. X and x will cancel, is equal to 0. Yes, you have factored out x, but what is remaining is actually the difference of two squares. X squared is a perfect square. 9 is a perfect square. This can be written as x squared minus 3 squared. So that means we are going to have x into 2 brackets of x and 3. So one is going to add, that is x plus 3. Another one is going to subtract x minus 3 is equal to 0. Or you just simply find the square root. The square root of x squared is x. The square root of 9 is 3. One bracket adds, another one subtract. So from this information, it simply means one of these brackets is equal to, each is equal to 0. So x is equal to 0, or x plus 3 is equal to 0, or x minus 3 is equal to 0. So definitely we are going to have the value of x as 0 here, or another value of x. 3 to the other side is going to be negative 3, or x is going to be minus 3 to the other side, which is going to be positive 3. All right, so that was the equation. Let's just see the other one, which is on 2.12. So for x again, but we are given that p is equivalent to 3 over 2x into pq squared minus pq squared, like that. So it's actually making x to be the subject of the formula. So this is same as p over 1. So we've got a fraction, so we can even cross multiply. So on cross multiplying, here is the 2 in the denominator that is going to affect p. All right, this expression, guys, is the same. Let me not rush here. Let me show you something. This statement is the same as writing as P is equal to 3x into PQ squared minus PQ squared, like this, everything over 2. That is what it actually means. So you can use this simpler version if you do not understand what it means. All right, so you can cross multiply 2 times P here. That's 2P is equal to 3x into P, this and that. But you can check that P is common here, so you can even factor out the P. So you're going to be left with Q squared minus Q squared. All right. The major or the objective here is to find x, or to make x to be the subject of the formula. So x is being multiplied by all these numbers. So we divide by the numbers which are multiplying, which is 3p into q squared minus q squared, both sides. So we're going to divide also here by 3p q squared minus q squared. So this would definitely cancel out with this, and we remain with x. So therefore, our x is going to be this and this, but here we can see that the p and the p outside can cancel. So this p and this p outside of the bracket can cancel. So it's going to be 2 over 3 into q squared minus q squared. So that is the value of x. You've simply made x to be the subject. So the question is simply saying, is simply asking you to make x the subject of the formula. All right. On 2.13, we are still given an equation, but under exponents are actually an additional equation that you can actually work with that, or exponents is just one and the same thing. So in this case, we are given that 3 by 4, x to the exponent of 4, that is 2.13. All right, 3 by exponent to the x to the exponent of 3 over 4 is equivalent to 81. So what can we do? All right, the first thing that we can have here is the 3 that we focus on. The 3 there is multiplying, so we can divide by 3 both sides to remove these 3. So you can remain with x to the exponent of 3 over 4 equal to 81 divided by 3, which is 27, or you can just use your calculator. 81 divided by 3, that is 27. So this is going to be equal to 27. So from our laws, we need to find the value of x. So we just need to find the inverse of this number, because x is in the base, and we've got an exponent of 3 over 4. So you simply need to find the inverse of 3 over 4, and the inverse of 3 over 4 is 1 over 3 over 4. That is the inverse, which is going to give us 4 over 3, or just have to invert this. So you multiply the exponent by its inverse, and on 27 is same as 27 to the exponent of 1. So you multiply also by the inverse, which is 4 over 3. So this will automatically cancel. You can even cross-check on your calculator. Here, where did I put my calculator? Sorry for that, guys. I need my calculator. Okay, it's here. So we can even cross-check here. That's 3 over 4 multiplied to 4 over 3. You can just check and see what are we having. Guys, look what is happening here. 3 over 4 times 4 over 3. And this is going to give us a 1. So as you can see, we're obtaining 1. This you're supposed to know it. I'm just showing you that is the same thing, guys. So it's 4 to the exponent of 3. 1 times 4 over 3, which is 4 over 3. So remember, you're asked not to use a calculator. So you're supposed to use the laws of exponents. So from our laws of exponents, we understand x to the exponent of a over b gives us the bit root of x to the exponent of a, or it can be given as the bit root of x everything to the exponent of a. And I favor to use this one. So we can actually apply that as x is equivalent to the b, which is the 3, so it's the cube root of 27, everything to the exponent of 4. So it's going to obtain the cube root of 27, a number which multiplies itself 3 times 27, which is 3. And whatever that we get to the exponent of 4, so 3 to the exponent of 4, if 3 multiplies itself 4 times, it gives us 81. So that is the value of x. All right, I think it was pretty clear. All you need is to work on match questions, as I always say, guys. 2.2. So for x on 2.21, we're given an inequality that is 2.213. That's 3 into 2 minus 3x is actually greater or equal to 15. So there are so many ways you can expand the brackets by 3, or you can choose to divide by 3 both sides, because 3 is not actually affecting. So if we divide by 3, we are remaining on this side with 2 minus 3x, which is greater than or equal to 3 into 15, or 15 divided by 3, that is 5. Since we need the value of x, we can transpose the other part of the inequality, which is the 2, so the 5 there, so it's going to be a negative. So it will be minus 3x is greater than or equal to, this is now 5 minus 2, which is 3. So to find x, we divide by -3 by -3 both sides, but minding that the moment you divide by a negative, if you are dealing with inequalities, the inequality sign must reverse or is going to reverse. So this is going to be less than or equal to -1. So that is the inequality that we are having. X is less than or equal to 1. Then on 2.22, hence represent your answer to question 2.21 on a number line, just number line, guys. Okay, so that is the number line. So that's 2.22. So as we know, our number line is supposed to affect the values of x here. So you can have our x is 0, -1, -2, and so on. So these are the values of x. So our x is less than or equal to -1. So you're going to -1 less or equal to, you shared the circle. If it is less or equal to, you shared. So the values which are less than -1, we are referring to -2, -3, -4. These are the values which are less than -1. So you indicate with an arrow. That's a number line. All right, so the arrow is indicating the values which are less than -1 from the number line that you have shown. All right, so that's what you actually needed on 2.22. All right, so I'm just going to remove this part so that we can check our 2.3, where we are given solve simultaneously for x and y. So we're given the simultaneous equation to solve. We worked with substitution on another part. So this time I'm just going to explain the elimination method. Elimination by substitution together. So what you're going to do is to have the two equations with the variables on one side of the equation, just like what we had on the first equation. 3x plus 2y is equivalent to 13. The second equation here, we have got 3x, which is fine. Then we transpose -y to this side, is going to be a positive y is equal to 2. So already we can see that on our first equation and second equation, the 3x are the same, the variables here are the same, and the coefficients of x are the same. So you can subtract the second equation from the first equation, that is equation 1 minus equation 2. So if we subtract these, what are we going to have? Because we need to eliminate x, to remove x, because that's where we have x, which is the same. So you're going to subtract, the signs are the same there. So let's subtract 3 minus 3, that's a 0. 2 minus 1, this is y, which is same as 1y. So it's 2 minus 1, which is y, is equal to 13 minus 2. 13 minus 2, which is equivalent to 11. So we have the value of y, which is 11. So to find x, you simply substitute into any one of these equations. So I'm just going to use the first one, or just use any, guys. All right, so I'm just going to take the first equation here, where we are given that 13x plus 2y, of which our y is 11. So it's 2 times 11 is equal to 13. So 13x plus 2 times 11, that is 22, is equal to 13. So 13x is equal to 13 minus 22, which is actually -9. Or you can use your calculator. 13 minus 22 here, which gives us -9. So that's it. So we can divide 13. Where am I having 13x? This is 3x, not 13. I hope someone saw this part to say, where is the 13 now coming from? All right, that's the 3x there. So you can divide. So x is equivalent to 3 into -9, that is -3. So this is 3x, not 13x. All right, so that was you actually needed on question number 2. Yeah, that was question number 2. And you can actually obtain 17 marks by doing this in exam. That's a lot of marks in exam, guys. That's a lot, I don't want to lie. So all you need is to revise as much question papers. I want you to do that. It can help you a lot. All right, on question number 3, we are now given a linear pattern, 2x plus 2x, 3x plus 4, 5x plus 6, and so on. That's our linear pattern. So we're given on 3.1, if x is equal to 0, calculate the numerical value of the fourth term. If x is equal to 0, that's a 0 here, a 0 here, a 0 here. So we are going to remain with 2, 4, 6. All right, so that's what you're going to remain with as a new expression. So now we are given to calculate the fourth term. So you're given is a linear term, so you have to check the difference here. So if we check our difference, we've got T1, T2, T3. T2 minus T1, that's 4 minus 2, which is 2. 6 minus 4, which is 2. So we've got a common difference of 2 throughout. So that means the next term, we are going to add 6 plus 2, which is going to be 8. So that was the fourth term, which is equivalent to 8. All right, hence, determine the nth term of the sequence. All right, so to find the nth term, that's our Tn. We already have the second, we already have the differences, this and that. So I want you guys to understand this formula. There are so many ways. I'm going to explain other formulas, but I want you to understand, it's going to be best if you know this formula. Okay, Tn is equivalent to A plus n minus 1 times D. That's the formula for the nth term of an arithmetic pattern or a linear pattern, whereby you are saying A is the first term, n is the number of terms, and D is the common difference. So that means Tn is equivalent to A, which is the first term when x is equal to 0. Our first term is 2. So it's going to be 2 plus n minus 1. Take note, we do not have the value of n. Then D is the common difference, which is 2 that we see throughout. So you multiply by 2. So therefore, your Tn is going to be 2 plus, you can expand brackets, 2 times n, that's 2n, 2 times minus 1, that's minus 2. So you can collect like terms here, 2 minus 2, that is 0 here. These two cancel. So we are going to remain with 2n. So that's the expression for Tn. So like I said, there are so many ways. I'm going to explain as we are moving, as we are revising. Let me know the areas. Now calculate the value of the 18th term, and that's to mark the 18th term. So that's 3.2. Our n now is equal to 18. All right, so that's 3.2. So given that n is equal to 18, what is T18? So T18, you simply substitute on Tn because Tn is equal to 2n. So it's 2 times 18 in place of n. And 2 times 18, that is 36. So that is T18. All right, just like that, for 2 marks. Then on 3.3, which term of the sequence will be equal to 108? So it means Tn is equal to 108. So that's 3.3. When Tn is equal to 108, what is the value of n? Already Tn, we have got Tn, which is 2n. So 2n is equal to 108. You have formulated an equation that you're supposed to solve for n. So by dividing by 2 both sides, our n can be equal to 54. So that is the term, the number, the value of n that you're going to have at that condition. On 3.4, we are now given to determine the largest value of n, for which Tn is less than 166. All right, so Tn is less than 166, and we are given here that, okay, let's write Tn is less than 166. We have the value for Tn, which is Tn is 2n. So 2n is less than 166. So if you divide by 2 both sides, you can find the expression or the inequality for n, because that's an inequality here. So 2 into 166, that's 83, or you can just divide from your calculator, that's 166. All right, divide by 2, which is going to be 83. So n is less than 83. So which integer do we have that is less than 83? The largest integer, that's 82. You just check the integer just before. All right, that's how you attempt this question. All right, the following values are multiples of 5 from the pattern, 5, 10, 15, 20, and so forth. Determine the 16th term number of this pattern. So this is the 16th, okay, even number of this pattern. We are dealing with even numbers. So actually, if you have got a question like this, you can take advantage of that Tn part that I talked about. But this time, your Tn is going to be focused on even terms because we are dealing with even terms. All right. So for even terms, the first even number that we have here is 10. Second one followed by 20. So it's 10, 20, and so on and so on. These are the even terms. So we are supposed to find a new expression for the nth term for the even numbers, which is Tn is equivalent to A plus n minus 1 times D. But this time of the even numbers, these 10, 20, 30, 40, and so on. So we are given that we are supposed to find the value of n when they determine the 16th even term. So n is equal to 16 at this moment. So we are asked to find the T16 of the even numbers. So T16 is equal to A being the first term. So that part does not change. A is still the first term, which is 10, plus n minus 1, which is this number of terms. We've got 16. So it's 16 minus 1 times D, which is the difference. Now there is a new difference because if you are to cross-check, this is now your first term, this is now your second term. So T2 minus T1, that's 20 minus 10, which is 10. So we now have a difference of 10, not that one that we had before. Okay, so T16 is equal to the answer that you're going to obtain here, which is 10 plus 16 minus 1 here, that's 15. And 15 times 10, that is 150. So if we add this, we are going to obtain 160. So that's our T16 if we are dealing with the even terms, only dealing with the even term. So that was our question 3, having a total of 14 marks, which is a lot, that's a lot. All right. Question 4, finance. We are now on financial mathematics. So we are given that Sylvia wants to buy a DeFi fridge. This one, not a fridge. Okay, there's those DeFi fridges I'm used to. Okay, so this one wants to buy a DeFi dishwasher, which is priced at 9,899 Rand by means of a hire purchase agreement. All right. The conditions of the hire purchase agreement are as follows. Sylvia must pay 30% deposit of the hire purchase. The interest is charged at 12% per annum, simple interest on the balance. Compulsory monthly insurance premium of 65.30. The balance must be paid in monthly installments, and the account should be settled in 36 months. So it's like the information that you're given. So you're going to get our answers from this information. All right, let's check the first part of the question. We are given that on 4.11, calculate the balance after Sylvia has paid the deposit. Okay, so take note, the deposit is actually 30% of the purchase price, and the purchase price is 9,899. So we are going to subtract the total minus the 30% on the amount that we had. Or you can simply say, since this guy is going to deposit 30%, therefore it means 100 minus 30% is the one that is going to remain as the balance. So the balance is 70% of this amount. That is the balance. Or you can use that method that I was referring to calculate 30%, then we subtract that one from 30%. All right, so let's see what we can do here. So this is 4.11. So we are going to have 30% of the amount that is the deposit. So let's see the deposit first. That is 30%. 30% means 30 over 100 or 0.3 times the amount that is priced, which is 9,899. So we're going to multiply to 9,899. So that's it, guys. This will be the deposit. So what do we have here? All right. So that's 30 over 100 or 0.03. 0.03. Okay, 30 over 100 multiplied by 9,899, which is going to give us 2969.7. So it's 2969.7. But this is amount, so you're supposed to have your answer to 2 decimal places. So now, after depositing this, what is the balance? The balance is the remaining one from this total amount of 9,899. We subtract that. So we're going to subtract the deposit. All right. So we are going to subtract. So it's going to be 9,899 minus the deposit of 2,969.70 because we are told that. All right, so that is the difference that you're going to have as is going to be the answer there, which is 2969.70. All right, that's 6929.3, which is 6929.30. Remember, this is amount, so it's supposed to be 2 decimal places. So I've got the balance. Or like I was saying here, that since this guy is paying 30%, then the balance is simply 70% of the total amount that was supposed to be paid. So we can even calculate that way. Let's see if we are going to get the same answer. The balance can be 70% of the initial price. All right, that's 70%, which is 70 over 100 times the initial price, which is 9,899. So there you simply find your answer direct, no complications. So it's 70 over 100 or 0.7 times 9,899. So we can have our answer as 692. As you can see, we're obtaining the same answer, 6929.30. Okay, so that was the balance. Then let's check the other part of the question. Calculate a monthly installment if the settlement must be settled in 36 months. What is the monthly installment? What is this guy going to pay in a month? That is the question. So in this case, guys, we are supposed to be very, very careful. We are supposed to be very, very careful. Remember, it's paid under a hire purchase, and under a hire purchase, that's a simple interest. So what is going to happen is that originally this guy was supposed to pay 9,899, but because there is a deposit, there is an interest rate which is there. Take note, there is an interest which is charged at 12% per annum, simple interest on the balance. So this is affecting the balance that we had, which is this balance that we got here. So we are going to see this amount accumulating at the end of the period. All right, so we can have something like this, hire purchase, that's simple interest. So the amount is going to accumulate, which is P plus 1 plus IN. So the amount is the one that we need to know after it has accumulated so that we can calculate the monthly installment. All right, so our amount is going to be equal to the P, which is the balance that we had because it's charged on balance, and the balance is 6929.30 or just 0.3. You can just leave the 0 in calculating. There's no effect. 1 plus the interest, I is the interest. So take note, it's now charged an interest of 12% per annum. All right, so 12%, that's 12 over 100, which is 0.12. So it's going to be 0.12 times any, which is the number of years. Take note, this you have to take 36 months. So referring to 36 months, that is 36 divided by 12, which is 3 years. So we are going to multiply by 3. All right. So that is going to give us the total amount which accumulated to. So it's 6929.3 bracket 1 plus 0.12 times 3. All right, so let's see what is going to happen. This is going to accumulate to 9,423.8448. But if we round, it's going to be 85. So it's going to be 9,423.85. Okay, so this is the accumulated amount that is supposed to be paid under a hire purchase. So now the monthly installment, we are going to consider this amount as, all right, let me write here. So our monthly installment is going to compose of 2 things here. We have got monthly installment, all right, which is going to be the amount to be paid, 9,423.85. But it's paid within 3 years, which is within 36 months. So since it is monthly installment, you divide by the number of months, which is 36. All right, this was supposed to be the original value, but take note what happened here of this guy. there is a compulsory insurance premium of 65.30. So the insurance is added to the monthly installment. So you're going to add the insurance, which is 65 Rand, 3. All right, like that. So that's what you're going to have. So you can even use your calculator here. That's 9423.85. All right, that's 0.85 over 36, whatever that we get here, we add to 65.3. All right, that's the answer that you're going to have, which is 327.07. Okay, so it's 327.07 Rand. So that was the monthly installment now with the deposit that we're given there. All right, so that was the consideration. Let's check the 4.2 of the paper, where we are given that the following table shows the exchange rate of the British pound and US dollar in South African Rand. All right, so the country USA, that's a dollar, it's equivalent to 16.24. So they are actually saying a dollar here is equivalent to 1 pound here is equivalent. That's what it means. So on 4.21, George, a visitor from England, saw an industrial textile machine on sale for $6,800. This machine is suitable for his business back home. The cost for the similar machine, but now in England, is £4,600. Calculate in which country will it be cost saving for George to buy the machine. All right. There are two options that you can actually work with. For you to calculate this, you can actually work with the conversion part here direct, or you can ask yourself to say, what is this amount in rand? Because we can compare this amount in rands. Or we can change one of these amounts, either pounds to US dollars, because we are given the conversion is already here. So there are two options. So I'm going to work with the longer one, even though it seems to be longer, but let's hope we are going to understand it. So what you're going to ask yourself is, what is the amount of $6,800 in rands? If a dollar is equivalent to 16.24 rand, what about $6,800 is equivalent to what? We do not know in rands, so that's going to be more, as we can see. So using your proportion, it's going to be 6,800 over 1 times that. So it's going to be 6,800 over 1 times 16.24. So we are now finding the amount in rands that is going to be paid, which is 6,800 times 16 rand,24. All right, which is 16.24 rand, which is 110.432. All right, 432. So this is going to be 110.432 rands. We do the same thing for the pounds, which means you're just going to multiply just like what we did. So this 4,600 pounds to rands, we are going to see it as 4,600 pounds over a pound, just like what we did on the dollar there, times, but the pound now is multiplied to 27 rand,63. So we're going to have our amount in rands here, so that we can compare which one is cheaper, which one is cheaper there. 4,600 multiplied by 27.63. That is going to be 127.08. Okay, so that's 127.098 rands. So this is what we had when buying in England and when buying USA. So as you can see, it's cheaper in USA. So it's actually cheaper in USA. As we can see, comparing the rands now, we can see 110 is less than 127. So it's cheaper in USA. All right, on 4.22, we are now given to install an outdoor swimming pool will cost you 800 pounds in England. How much will it cost you to install a swimming pool of the same capacity in South African rand? All right, so there we are supposed to get back to the conversion between the pound and the rand there. Remember, 1 pound is equivalent to 27 27.63. So that's where we are going to start from. A pound is equivalent to 27.63 rand. All right, so we have got a swimming pool now, which is at 800 pounds. So just like what we had there, we are going to multiply. So this is actually 1 pound here, not a pound one. So it's like 1 pound. So guys, just, I don't know the way I'm writing here. So what is the equivalent? So just like what we had is going to be more. So we're going to multiply 800 multiply by 27.63. Okay, just like what we had previously there. So if we multiply this, that will be the amount in rands to install the same swimming pool, which is 27.63 here. That will be 22,104. So it's going to be 22,104 rand. So that was actually the total cost in rand. So that's what we had, guys, on question number 4. We're having a total of 12 marks. So it's actually pretty clear. Yeah, it's pretty clear. We need to revise, guys, as much as we can. All right, on number 5, we are given a hyperbola whereby we are given the equation of the function gx is a over x plus q. As shown below, it passes through the 0.42. That's the 0.42 that is indicated on the graph here. And we are given the range is from minus infinity to 1 and 1 to infinity. So these are the values of y. That's the asymptote. So which means we've got an asymptote at y is equal to 1. It is not going to pass this line of y is equal to 1. So that's an asymptote there. So that means q is equal to 1 also, because q represents the asymptote. So q is equivalent to 1, and for x, the asymptote is equal to 0. Okay, anyways, I'm just analyzing what we have there. The first part on 5.11 was to determine the equation of g. All right, determine the equation of g. So to find the equation of g, all right, remember we talked about the asymptote here. So that was 5.11. We can even work it here. 5.11. So remember that our gx is given as a over x plus q. So this is given as gx is a over x plus q. So from this part, remember we said q is the asymptote. So q is equal to 1. So you can even substitute the value of q, which is a over x plus 1. So we are now left with finding the value of a. So you can utilize or take advantage of the 0.42 that we are given. So using the 0.42, we are given the value of x here and the value of y. So y is 2 in place of gx. 2 is equal to a over x, which is 4 plus 1. So we can find our a, we can transpose 1 to the other side of the equation, which is going to be negative 1. So it's 2 minus 1, which is 1, is equal to a over 4. So cross multiply, a is equivalent to 4. So therefore, g of x is equal to a over x, which is 4 over x, plus q, which is our q is 1. So it's going to be plus 1. So this is our equation for gx. Yeah, that's what we had. Yeah, that's what we had. Let's just see what we have on later on. So later on, we are now given to find the equation of h, the axis of symmetry of g, which has a positive. This is the most important part. It has a positive gradient. So what you need to understand is that when you are dealing with the axis of symmetry, the first thing, it passes through the asymptote. That is what you need to know. All right, it passes through the point, which is the asymptote, where we said y is equal to 1. If you can even check here, y is equal to 1 and x is equal to 0. So at the asymptote, x is equal to 0, y is equal to 1. It's actually a point of intersection of this 0, 1. So the equation that has got a positive gradient is given by the form or the equation y is equal to x plus c. We know that if it has a negative gradient, it was going to be y is equal to minus x plus c. So the equation is of the same thing or same nature, but positive, it remains as positive x. So you can substitute the value of x that we have and y here. We have got a point x and y. So y is equal to 1 when x is equal to 0. So you've got c. So that means c is equal to 1. So therefore, the equation is going to be given as y is equal to x plus c, which is 1. So that's the equation of the axis of symmetry, and is the equation of h. So we can write this as hx. All right, that's the equation of hx. So hx is equivalent to x plus 1. So that's our equation there. All right, so let's see the other part of the question, what we were given. All right, on 4.2, we are now asked to sketch the graph of H on the provided diagram sheet, which is, okay, so in this case, I do not have that diagram sheet. I'm going to sketch it here. Remember HX, showing all the intercepts with the x's. All right, so that's what we had. So I'm just going to sketch it here because already we've got our graph here. So remember that our HX was equivalent to x plus 1. So we need the x-intercept and the y-intercept. So the x-intercept is when y is equal to 0. Where y is equal to 0, we're going to have x plus 1. So we can transpose. -1 is equal to x. So x is equivalent to -1. That's -1. Okay, let me write it properly here. So x is equivalent to -1. Then for the y-intercept, we know that x would be equal to 0, and we can even check here. If x is equal to 0, we just substitute here as 0. So it's 0 plus 1, y is going to be equal to 1. So y is 1. So from our graph here, we're just going to mark those points. X is equal to -1 and y is equal to 1. We can just utilize this graph. So x is equal to 1 is at this point. Y is equal to 1. And x is equal to -1 is at this point. So all you needed was to use your ruler. Then you draw, you actually have to join properly. So you were given a graph to use actually. So as for me, guys, I do not have that sheet. So, okay, so I'm just going to use this part. All right. So on that part, now on 5.3, we are given 5.3. All right, there. So, okay, everything is there. Write the equations of the asymptotes of f of x, which is equivalent to negative gx plus 3. Okay, the equation of the asymptotes. Okay, that's 5.3. Where do we have our gx? So let's see, this is where we have our gx. So you can take this from our gx here. We are now given a new function. Okay, that's 5.41. All right, so it's another function that we are given. That was 5.4, 5.3, 5.1. Okay, that's 5.3. All right. So we are given a new function here of f of x. That's 5.3, where we are given that f of x is equivalent to negative gx plus 3. So what does it mean? It simply means we are going to substitute what you're given, negative in place of gx. This is our gx, which is 4 over x plus 1. So it's going to be 4 over x plus 1. Whatever that we get here, we add the 3. Take note, 3 is there. So then from there, we can actually determine the asymptotes. Remember, we can take asymptotes from the equation, just like any other equation. So it's negative times 4 over x, which is negative 4 over x, negative times 1, which is negative 1 plus 3. So you can collect like terms. So f of x is equivalent to negative 4x, negative 1 plus 3, which is 2, positive 2. So the asymptotes will be taken from x. As you can see, there's nothing that is adding or subtracting to x, so x will be equal to 0. And y is positive 2. The value of y is this one that we have. So y is equal to 2. So that's it. The value of y, you take this number as it is. If it is a positive, you take it as a positive. And negative, you take it as a negative. So those are the asymptotes. All right, use the graphs to determine the values of x on 5.4, for which on 5.41, we are now given gx is equal to hx. So the problem that we had is that as we just draw a line, we didn't do this accurately. It was supposed to be done on a graph. So, but on that graph, actually, it's only that I do not have the graph here. But on the graph, actually, it was here at these 2 points here. The point of intersection was at this point, which is equivalent to -2, and this point, which was equivalent to 2. So when you're referring to when the graphs are equal, that is at the point of intersection. You take your values at the point straight, you are going to reach -2, and straight you're going to reach 2. That is what you're going to see from your graph, but it's only here. I just did it on this graph, but on the actual graph, this was going to reach at -2, and another x was going to be at positive 2. All right. 5.42, for which values is gx less than hx? All right, we need a condition where gx is less than hx. What does it mean? It means gx is actually below hx from the graph. So let's check where G is below H. Okay, this is our H and this is our G here. Okay, we can check from this part. G is above H, it's above, up to point -2, it goes below. All right, up to definitely the asymptote at x is equal to 0. So from -2 up to infinity, up to the asymptote here, it is below. The same thing happens at the point of intersection of 2 here, from 2 going this way up to infinity, up to, I don't know the values there, it is still affected, it is below. So which means we can take our values from -2. Okay, let's check another thing. Sorry for that. Let's check if we have got we are given a consideration also here where x was. I'm worried about the marks. Okay, where x is less than 0. So we are going to work with this side only. X is less than 0. That is this side. So this is our x here. We've got x, which is 0 minus 1. So we are focusing with this side alone. So from this side, that means our answer is going to be from -2. So our x is going to be greater than or equal to -2, but it won't reach the infinity. Now, it won't reach x is equal to 0, which is the asymptote here, because remember, this is the y-axis, which is the asymptote. So our x is going to be less than 0. It can't be equal to 0. You do not have a value that can be equal to 0 because that's an asymptote. So there is nothing like that. So x is going to be less than 0, not equal to 0. So be careful. Be very, very careful there on this typical part, because you might end up using less or equal to 0, because here there is less or equal to no. On that 0, it can't, because that's an asymptote. Okay, so that's what we had, guys. Actually obtaining 16 marks on question number 5. That's a lot. That's a lot. Okay, on question 6, we are now given f of x is equal to 3 to the exponent of x minus 1, and another gx, which is 1 over x. Sketch the graphs of f and g on the same set of x's using the provided diagram sheet. Right, and I do not have that diagram sheet, so I'm just going to use what we have. All right, so we're given two functions on question 6. That's 6.1 here. All right, so 6.1, let's just indicate here. So we've got two functions, the f of x, which is 3 to the exponent of x minus 1. So we're given f of x, which is 3 to the exponent of x minus 1. And another function that was of gx, which is gx is equivalent to 1 over x plus 1. Okay, that was 1 over x plus 1 plus 1 plus 1 plus 1 here. All right, so it's actually in the denominator like this. All right, so these are the two functions that you're supposed to sketch. Let's start with the f of x. It's actually here we are working with an exponential function. If it was 3 to the exponent of x is equal to just 3 to the exponent of x, we will be having the asymptote at y is equal to 0. But there is a -1 here, so which means we shall have y is equal to -1 as our asymptote. All right, so that's what you're going to have on this one. So we shall have something of this nature. Okay, this line is ugly. All right, something like this. All right, so I'm just gonna indicate my x here, my y here. That's 0, 1, 2, 3, 4, 5, 6, -1, -2, -3, -4, -1, -2, -3, -4. All right, 1, 2, 3, 4, something like that. All right, so we've got the asymptote at y is equal to -1, so which means the graph is not going to pass through the line of y is equal to -1. So you can even draw this line as a continuous line. It's not a matter of fact. So you can just have y is equal to -1. That's your asymptote, which means the graph is not going to pass through this line. All right, so when x is equal to 0, let's see what you're going to have for the y-intercept now. If x is equal to 0 here, so x will be equal to 0. That means y is going to be equal to 0 minus 1, which is -1. All right, but we say that's an asymptote and it's passing through -1. All right. No. This is 1 minus 1, which means a 0. Sorry, it won't pass. This is 0. That's 1 minus 1, which is a 0. What? Why even surprised how this function is now behaving like this? Okay, so that's 3 to the exponent, which is 1 minus 1, which is a 0. So y is equal to 1. All right. Then only condition where y is equal to 0 there, there's nothing that you're going to, let's see. If y is equal to 0, that's for the x inter. Y will be equal to 0. So 0 is equal to 3 to the exponent of x minus 1. So you can transpose to that side. So it's going to be 1 is equal to 3 to the exponent. So that one is going to be 1. 3 to the exponent of 0 is equal to 3 to the exponent of x. So x is going to be 0. So it's 0 and 0. So this one, it is just going to pass through 0. And we know the shape, remember the shape of an inverse function. All right, so it is going to be like that, passing through 0, 0. But this is the asymptote now. It is not going to reach this value of -1. So it's going to be like this, above -1. It's going to pass through 0 here, okay, through 0, 0, and so on, and it goes up somewhere there. All right, so that's what you're going to have. So this is our f. Okay, let's focus with g. Gx is equivalent to 1 over x plus 1. So there are asymptotes here. We have got the asymptote at y is equals, we do not have the value of y, so it's y is equal to 0. And here, x plus 1 should be equal to 0. So x is equal to -1. So we have the asymptote at x is equal to -1 and at y is equal to 0, which is in the x-axis. All right, so where x is equal to -1, that's our asymptote here. So it is not going to pass through -1 like that. For g, not for f, this is another function. All right, so on this function, it's a positive. So suppose we are expecting to have the shape like this or like that. This is the shape that you're supposed to have on a hyperbola. So let's have our x and y intercepts. You can even calculate here on top. All right, so let's just do this. So let's start with the x-intercept. For the x-intercept, we know that y is equal to 0. So if y is equal to 0, here we're going to have 0 is equal to 1 over x plus 1. So you can cross multiply. There's nothing that is going to happen because when y is equal to 0, it's an asymptote here. So there's nothing that we can get. All right. So that means we can only have the y-intercept on this one. For the y-intercept, we know that x is equal to 0. So if x is equal to 0 here, that means y is going to be equal to, that's 1 over 0 plus 1, which is 1 over 1, which is 1. So we've got the y-intercept at 1. So we are going to have our y-intercept at 0.1, which is somewhere here. That's our 0.1. Okay, so our graph, guys, we agree that it has the asymptote in the line y is equal to 0 and the line of x is equal to -1. So that means we shall have a shape like this. Yeah, let me just change the mark. We shall have a shape like this, trying to approach -1, but it won't approach this. To the 1 on the y-axis, it's going to pass through 1 in the y-axis. Then it will be as if it wants to approach the x-axis, but it won't approach because that is an asymptote. So that's what you're going to have. And definitely another curve on the other side. As we know, it won't reach the y-axis, but it will be as if it needs to reach, but it won't reach the y-axis. So it will be like this, below the y-axis, and at the asymptote, it won't reach the asymptote, then it goes down, goes down, it goes down, it won't reach the asymptote. All right, so this becomes our G. All right, so G on this side. So that was it, guys. We have got our F and we've got our G. As we can see, they will intersect at this point, and at that point, that's just an approximated point. We do not know if exactly is the exact point. All right, then after sketching the graphs on 6.2, we are now given, using your graph, write down the coordinates of the point of intersection using your graph. So now that's where the danger is coming on now, because we did not use the graph. So actually, that's where the danger is actually coming from. So it's going to be a disaster on this one to attempt this. But on your graph, if you are using an actual graph, you're going to take your points of at this where they are intersecting. That's where you take your values. All right. Anyways, that's what you're going to do. On 6.3, all right, what is the range of f? The range, remember, we are talking about the values of y, okay? So the range of f is going to be determined here. This is our f. Remember, our f is limited to y is equal to, this is your f here, it is limited at -1 when y is -1. So that means it won't be able to reach this value. So it is going to go from any value that is above -1 going up. So all these values going up, they are greater than -1. So y is greater than -1. That was actually the given range. All right, so that was direct actually. 6.4, write down the domain of G. Okay, how many marks do we actually have here? It's just 2 marks. Okay, the domain of G. G, we are talking about the x values now. And for G, we can see that it is affected at x is equal to -1. It won't reach the value of x is equal to -1. That's very, very, very impossible. It won't be able to reach that value. So x is going to be, we're talking of G. Okay, G. So x is not equal to 1. So that's what we have on 6.4. So x is not equal to -1, but this x is actually an element of all the numbers that we shall have, but not equal to -1, guys. We have to move G, not f. But if it was for f, then it's actually from -infinity up to infinity. If it was for f, not for G. For G is going to be limited at -1. All right. Then on 6.5, write down the equations of the asymptotes of G. What did we have as the asymptotes on G? All right, so the asymptotes, we already found them already. Remember, we already indicated these asymptotes where we said x is equal to -1 and y is equal to 0. Now we are just writing them. All right, so now he's just writing them down. So x was equal to 1. Is it 1? Is it 1 or -1? This is 1. All right, x is equal to -1. All right, so x is equal to -1 and y was equal to 0. So that's what we had. All right, 6 point, sorry for this. On 6.6, determine the values of x for which gx is less than 0. Gx is less than or equal to 0. Where x is less than -2. So x is supposed to be less than -2. X is less than -2 at certain point here. And our G, remember this is our G here. That's our G, this one in green here. So our G is actually, where is it less than? At this side here. And this side, that's where we have got our x being less than -2. So already they've given us the answer here. So x is actually less than -2. Guys, these guys, they sometimes play with you guys. They just want to test you. So already x is less than -2 on that one. Okay, so that was actually question 6. And yeah, it was a lot. It was actually carrying 15 marks, which is a lot, guys. You need to understand this concept. All right, so let's check the question 7 that we are given. So on question number 7, we are given that an entire sample space is made up of 2 complementary sets. Okay, there are 2 complementary sets, which is S and T, where the probability of S complement, so this is S complement is 0.33. Remember, S complement means not in S, it's not part of S. Okay, 7.11, complete the statement. This is direct, guys. Probability of what is in S plus the probability of what is in T. That's everything in the sample space, so it's equal to 1. All right. Write down the value of probability of what is in T. All right, remember that we are given only 2 sets, S and T. And we are given that the probability of what is not in S is 0.33. If it is not in S, therefore, where is it? It is in P. So it is in T. So the probability of what is in T is the same as the probability of S complement, which is 0.33. So that was actually the idea of the question. On 7.2, we are given that there is a survey which was conducted among 180 residents in a small town to establish how many people contracted tuberculosis, which is TB, or human immune deficiency virus, which is HIV, during the last 5 years. The results were as follows. So you're given a survey of those who contracted TB and also contracted HIV/AIDS. Not HIV/AIDS, but just HIV, guys. These are two things, okay? So this is HIV and TB. So we are given the first part that the results were as follows. X people were diagnosed with TB, 30 were diagnosed with both TB and HIV, 69 were HIV positive, 51 did not have either disease. So represent this information above in a Venn diagram. All right, we need a Venn diagram for this. All right, so what you're going to do is that we've got two sets. I can just even utilize this space here. All right, let's just utilize this space. So we just have two sets that we have. And do we have any part, okay, that is on the intersection? Okay, I need to change here. All right, do we have anything on the intersection? We have got 30 with both, they have got both TB and HIV. So which means there is an intersection between the two sets. So we shall have our two sets with an intersection like this. So we've got those with TB and those with HIV here. And they are those without these. Okay, 51 did not have either disease. So that means we need our rectangle here. So we're going to put the rectangle like this. Okay, just a rectangle like that is fine. All right, so from this information, that is the sample space having everything that we have. All right, so that was 7.2. So let's insert the values and see what we have. In the sample space, we've got the total number of people, which is 180 residents. Maybe these are people in a certain town or a certain place, which is 180. Then from there, we are given that X people were diagnosed with TB. So TB, that's X in place of TB. The whole of TB here, they are X. All right. Then take note, this is not given as TB only. If it was written TB only, you substitute where there is TB only here on this point, but this is not TB only, so it's not like that. All right, then we move on. 30 were diagnosed with both. So 30 is going to be on the intersection. This is both TB and HIV. So you indicate your 30 on the intersection here. All right, then from there, we are given that 69 people have HIV, were HIV positive, which is 69. So for HIV, they are 69 on this part here. So what are you going to do to find those who are HIV only? So you subtract both, the whole of this set of HIV is 69. So to find the remaining part, you're going to subtract 69 minus 30, which is 39. So which means HIV only is 39 without those who are having TB. The same thing here, to find the TB only, they are X with TB and 30 with both TB and HIV. So to find TB only, it is going to be X minus 30, like that. All right, so that's what we have for the information. Then let's move on. We are also given that there are 51 people did not have either disease. So which means we've got 51, which is outside of TB and HIV. So we are going to have our 51 here. So that was your Venn diagram. Yeah, that's it. Do not have any information which is left out. On 7.22, we are now given how many people contracted TB only. Take note, TB only. So we need where this part here of X minus 30. So the best thing definitely we have to find the value of X, because we do not know the value of X. So where are we going to have the value of X? We can find the value of X from this information that we are given, that the total number of people who were in the survey is 180. So if we add everything that we see here, it must be equal to 180. So that means X minus 30 here plus this 30 plus this 39 plus this 51 outside must be equal to the sum, which is 180. So you can add everything here, but as you can see, guys, minus X plus X, that's a 0. So you're simply adding 39 plus 51, or you just add everything. All right, you see, you get the same answer. 39 plus 51, that is 90. So you're going to have X plus 90 which is equal to 180. So to find x, definitely transpose 90 to the other side is going to be negative 90. So 90 minus 90, 180 minus 90, that's a 90. So our x is 90, but take note, we are not calculating x. We are calculating those who contracted TB only. So in this case, TB only is equivalent to x minus 30, which is our x is 90. So it's going to be 90 minus 30, which is 60. So 60 had TB only. So that was the presentation that we had, and it was direct, as you can see. 7.23, calculate the probability that a person selected at random will only have been diagnosed with TB. So it's only that part that is of TB, only TB. And only TB, we got that those with TB only is 60. Now it's probability. So probability, remember that is the required outcome, which is 60, over the possible outcome, which is the total of 180. So you can reduce this, which is going to be 1/3. All right. B, we will not have any of the two diseases. So the person in the survey will not have these diseases. So as you can see, there are 51 people who are there who do not have any of these diseases. So it's going to be the required outcome, which is 51, over the possible outcome, which is 180. All right, so you can write it as 51 over 180, or you can write it as a decimal. That's 51 divided by 180 here, which is going to be 0.283333, which is 0.28 to 2 decimal places. Remember, your instruction is supposed to be to 2 decimal places. So that's what we had, guys. And as you can see, these are the typical questions, and you have to be very, very careful how to attempt these typical questions by revising much questions. Guys, let's try by all means to revise as much as we can, preparing for the exams which are ahead of time. So that's it, guys, for Mason African Motives. Still on the mathematics, grade 10 revisions till we meet again.